Hi, welcome to video 5.4a, Introduction to Derivatives and Integrals of Natural Exponential Functions. So we're moving on to exponential functions. So first of all, if you remember, we just studied the natural logarithmic function y equals ln x. That's the graph, goes through 1, 0, vertical asymptote x equals 0. Notice the domain, the x's are all positive, the y's are any real number. Now what we're going to do is look at the inverse of that function, which is f of x equals e to the x. Okay, 5.5 will do other ones, other bases, 3 to the x, a third to the x, but 5.4 is just e to the x. So y equals e to the x. It's a good thing to know what the graph looks like. And it's, of course, if you reflect this green graph over the line y equals x, you'll get this curve right here. So everything that was x becomes y. Here it went through the point 1, 0. Now it goes through 0, 1. Here it had a domain greater than 0. Now the range will be y is greater than 0. Here the range was y is all real numbers. Here it's x is all real numbers. This one had a vertical asymptote of x equals 0. This one has a horizontal asymptote of y equals 0. Keep in mind that e is a positive number, about 2.71. You raise a positive to any power, you're going to get a positive. That's why your answers are all positive. Nice to know what the function looks like, because then you can answer limit questions by just looking at the graph. Limit as x goes to infinity of e to the x is infinity. Limit as x goes to negative infinity of e to the x is approaching 0. And the limit as x approaches 0 of e to the x is 1. Okay, so here's our two new theorems. Very exciting. Derivative of e to the x is e to the x. Hence, the integral of e to the x is e to the x plus c. Now, of course, it's not always going to be e to the pretty little x. If it's the ddx of e to the ugly u, then it's e to the u times du dx. Same thing here. If you have an ugly thing here, you better have the duh that goes with it, the du. But as long as this is right here, the derivative of that u, that exponent, then you'll have e to the u plus c. Okay, so an example, for example, the derivative of e to the 3x squared minus 5 is itself e to the 3x squared minus 5, and then times chain rule times the derivative of that exponent. Same thing here, it's e to the cosine x times the derivative of cosine x, which is negative sine x, and then we just rewrite it. And what's going to happen here is, for the very first time, you're going to let u equal the exponent, and that's where the x is going to be anyways. Okay? So, for example, integral of e to the 3x dx, you're going to let u equal the exponent, which is where the x is. So I'm going to let u equal 3x, which means my derivative is 3 dx. So you come back and you go, well, I've got the dx. What I'm missing is the 3. So that's what I'm adding in black, counteracting with 1/3. You're now looking at 1/3 the integral of e to the u du, which is 1/3 e to the u plus c. Don't forget to change the u back into what it was, which is 3x. Derivative of e to the negative x will be e to the negative x times negative 1, which is negative e to the negative x. Turns out that the integral of e to the negative x also gives the same answer. Because if you let u equal the exponent, negative x, the derivative is negative dx. Introduce the negative counteract, and there you have negative e to the negative x plus c. Okay, let's say they ask you to find dy dx, and you have y equals the ln of e to the x plus e to the negative x over 2. Keep in mind that this is an ln. Use your properties. That's the ln of a over b equals ln a minus ln b. This is just a constant, so when you take the derivative, it'll be 0. The derivative of the ln of a thing is 1 over the thing times the derivative of the thing, which will be e to the x, plus e to the negative x times negative 1, which is where the negative comes from. And therefore, there's your final answer. As far as graphs go, they're going to ask you to graph various things. So here's our basic mother function again, y equals e to the x, rises, horizontal asymptote y equals 0, rises slowly until it gets to that special point 0, 1, then it takes off like crazy. So this, of course, is simply going to move the graph to the right one. So it's going to take that point 0, 1, which is where it starts to really take off, and move it to the right to the point 1, 1. Otherwise, things stay the same. Over here, the negative in front of the x will flip it over the y-axis. So instead of looking like this, it'll look like that, as you can see. The 1/2 is just going to affect the steepness, not to worry. e to the negative x, just the boring, just e to the negative x, we'll just flip it over the y-axis. If you have a negative out in front here, then it's going to flip it over the x-axis, and it's going to make it less steep. This one here is going to flip it over the y-axis and move it up 3. Now, of course, once you move it up or down, you're moving the horizontal asymptote as well. Now, again, are they going to ask you to graph these on the AP? No, but they could ask you limits about them. They could ask you areas and volumes, and you'll need to know what these graphs look like. Okay, old things with new people. Find an equation of the tangent line to the graph at the point 0, 1. So same old, we've done a million times, only the function happens to be an exponential function. So to find the equation of any line, we need a point, which they gave us. We need the slope, in this case, slope of the tangent line, so it's the derivative. The derivative of this is e to the negative 3x times negative 3. We're evaluating that at the point where x equals 0, giving us negative 3 as our slope. Therefore, the equation of our line, y minus 1 equals negative 3 times x minus 0. Okay. Here's another one. Find the derivative. Y equals x times e to the x. Sorry, fighting with my vertical blinds. You'll have to notice there's a product rule. It's x times e to the x. So it's first factor times derivative of second factor plus second factor times derivative of first factor. And there's your answer. Here's another one. Be careful. ln log base e of e to the x is just x, and the derivative is 1. I mean, you can go through the whole thing and do another way of looking at it is you could bring the x out in front by that log property and then hopefully realize ln e is 1. Another thing you could do is not notice a thing at all and actually do the derivative of an ln of a thing is 1 over the thing times the derivative of the thing, and therefore you will get 1.